All right. So this session, yeah. Before that, I'll go with my profile. So introduce myself. So my name is Pramod, and I have around 16 years of experience. I have worked with the product-based companies like Microsoft, and in past I worked with companies like HCL and Coforge. And in my career, I have been architect and engineering lead, software engineer, and multiple roles. And I have around 10 years of experience architecting large scale systems. And I have worked on the distributed systems, which are handling like petabytes of data and billions of transactions each month. And sometimes I have seen the peak load of 1 Tbps on the services which I was part of. Okay. And apart from this, I'm sharing my LinkedIn profile. You can connect me over there to learn more about me. Apart from my professional career, I am very good in basically helping others, and I like teaching. That is a hobby sort of thing. Nowhere I'm representing Microsoft here in this session, but just it is part of giving back to community and sharing my knowledge. And I have designed those systems which are being used by those billions of customers. And based on my learning, I would be sharing the designs which I think are correct. So these design interviews, basically for which you are here, are always like open-ended and kept vague to assess your skills on different parameters. And I would try to help you to uncover all areas from the interviewer's perspective, because I have been interviewing candidates for a decade. And what we are expecting exactly from the candidates as an interviewer, those areas I would like to shed light. All right. So, but yeah, I am sharing the agenda of this course. Basically, this is not limited to that, and I'll try to modify this based on your feedbacks and any specific need. Okay, so this is our first session. So we started with introduction, and we'll cover few basics. Actually, what we are going to cover in these sessions. So our first session would be around introduction to system design. What is system design, and who designs the system? What are the building blocks in any system design architecture, basically? And what is the design framework that one should use to answer the questions in these interviews? Then we'll go to like upcoming session. It's not specific like session 1 or session 2. I just kept to cover the topics I want to cover in this session. So another thing would be like we'll cover the LLD. So in LLD, we'll go through OOPS concepts and UML notions and diagrams. And in OOPS concepts, basically, we'll use the generic language and generic syntax, not specific to any language. But all those topics like inheritance, encapsulation, all those would be covered with examples. And then we'll cover the solid principles, because that is needed for any object-oriented design. You need to know the solid principles. Okay. Then we'll move to design patterns. In this, we'll cover all those gangs of 4 patterns. Not all patterns, but maybe all 3 categories. Few patterns with examples we'll take, so that you have a clarity about what is the UML diagram, how it looks like, and in what situations you should be using those design patterns, right? And then we'll move to basic things which are needed to design any distributed or high scale system. So not directly jumping to the case studies, I would like to cover all those aspects of what scaling is, what are load balancers, caching, CDNs, right? And we'll talk theoretical as well as the practical things, in what scenarios these components can be used to design a robust and high performance system. Okay. And as you all will agree, like networks and protocols are very critical and essential part of any system design, because now the technology is bridging the gap between the different devices and the platforms and services needs to interact, and using the basic protocols like IP, TCP, those are not sufficient. So there has been some advancement in technology and new optimization basically of existing protocols has happened in, and those are very frequently used in all these systems. So you need to know the basics of these principles about DNS, TCP, UDP, REST APIs, HTTP verbs, WebSockets, long polling. So all those things will cover in detail, and also so that you understand like in what situation when you are designing, you do not end up with over engineering or not knowing the features or functionalities which are already inbuilt in those protocols to establish communication between the systems. Okay, then next part would be databases. Database is integral part of any system design. Without storage or persistence, you cannot complete any design. So like we'll cover what are the features in SQL and no SQL, and we'll cover the acid and base properties, and we'll go through the concepts around Cape theorem, concurrency, and partitioning, like sharding, how you shard the database. That those things would be covered in DB design. So one thing maybe I didn't talk about in design patterns, we would cover some microservices design patterns also, because designing those scalable services becomes possible with microservices. Monoliths had some limitations. So microservices have a specific design patterns that would be helpful to come up with performance and come out of the limitations of the microservices using those patterns. Those will be covered, and then we'll also talk about the hashing and what are the hashing techniques in few of the sessions. We'll discuss about microservices and what are the stateful, stateless, and design patterns here. And then last part, like what are the different type of queues, like messaging, RabbitMQ, Kafka. All those things will be covered. We'll also try to cover in few sessions about the thread safety processes, concurrencies, and the rate limiting concepts. And in final leg, after having discussed in depth all these topics and having the knowledge of design patterns, you would be ready with the to implement basically HLD and LLD, right? So LLD basically will cover the design patterns and all. Along with that, I would take some case studies to design the class diagrams, use case diagrams, and all that. That is done. It would be done as part of design pattern and OPS concept. After that, we'll move to high-level design. In high-level design, we would cover some use cases and frequently asked interview questions like design a WhatsApp messenger or any chat messenger like that, or URL shortener. Those common, most frequently asked questions, but this is not limited. We'll based on your demand or consensus, we can take more studies, case studies, or I would take some real-time scenarios and give as a home exercise or as a class exercise, so that you all can collaborate and come up with a solution of those unique problems which are not listed in any platform or not very commonly used. Does that make sense? Give me a thumbs up if you are okay with this content.
Yeah,
I have a couple of questions and requests. So one question I have is in the network section, right? Can you hear me?
Yes, I can hear you.
Yeah. So in the network section, will you be discussing IP addressing, IPv4, IPv6, and subnetting?
Yeah, sure.
And in microservices, right? Will you be also covering authentication protocols like OAuth, OAuth2, API gateway, reverse proxy?
Yeah, we'll cover the concept basically that are frequently. So this is not a microservices course. This whatever is needed to answer the interview questions. Basically, that portion would be covered. So all the basic tenets of design pattern, like API gateways or stateless, stateful services, how the communication happens between those services, and what are the some design patterns to overcome the limitations which are supported in like monoliths and not possible. So
Right.
based on your
Yeah.
requirement, we can take the questions, and those topics can be added, but we would not go deeper into like designing the microservices. The idea of this course is not to teach microservices, but to cover those concepts only with respect to high level and low level design.
I got it. So I would request you to just add authentication part to the microservices, because sometimes in interview, they also try
Okay.
to check like how, in case it is a SaaS application, when you expose your API to third party, what are the approach you have for authentication and authorization. So please cover that.
Yeah,
Thank you.
that would be covered. Irrespective of microservices, any platform which you are building, distributed system, yeah, definitely there are authentication and authorization that is integral part of that. So yeah, that would be covered. All right. Yeah. Any other thoughts and questions?
And Pramod, I can see the syllabus, and do we need also some follow some book also, or will that this course will be enough?
Say that again.
Or do we need to follow any book also? If you can
Books.
recommend any
Okay.
book also.
Yeah, I'll be sharing few resources, online resources or books that apart from this course, obviously we would have a limited time, few hours only, like around 50 hours, and we would not be able to cover everything in depth, right? So whatever has been covered in the class, you can refer those materials in online blogging. So I'll share those URLs and links. You can take care while practicing and go online to get more detail.
Okay.
Just one query, Imran this side. Do we need to for system design interviews API level describe API level coding or like architecture,
Yeah.
like how we would be doing?
Yes. So we would be doing some case studies around that, and after covering the these pointers are just to cover those topics, not limited, like each bullet is not containing everything that we would cover. Definitely that would be more than that. So when we go to low level design, basically we know the design principles, oops concepts, and basically covered the APIs, RESTful APIs and protocols. Then we would go into like what are the API methods get put post, and what is request response model. So that would be covered. Okay. Any other questions? Any thoughts? All right. So let's get going with today's agenda, basically. So okay. Okay. So yeah, page here. Let me connect my. Give me a minute. Let's get started with basically the term system design. So when we say system design, okay, so what system design is basically, okay, so can someone volunteer and try to answer what do you understand by system? what is a system in this context of system design?
Okay, I think system is I think a combination of everything which makes your product work on wire.
Okay.
Means end-to-end thing, like including the connections and all, everything that includes security to everything that encompasses that application needs to run or application needs to be built. That's
Okay. Everything
Sir,
needed to
yes.
The
build a
whole
system.
the whole architecture involving hardware as well as software considerations.
Okay. Hardware plus software. Okay.
sir, something which processes the input and gives output is the system.
Okay. Okay. Input and gives output. All right. Yeah.
Architecture to have all the requirements for the product.
Okay. Okay.
A set of things to for a mechanism to achieve some kind of a mechanism. That's what, like,
Okay.
all
Mechanic.
all the logics of the requirement, like of the system, of the flow.
Okay. Cool. Yeah. Anything else?
The flow of pipeline, input flows from one stop.
Okay. Yeah. All right. All right. Thank you for participating. And these are all correct answers, basically. So if we say in one line, system is a way of doing something, right? If I summarize all your answers or all your thoughts, so basically, if we say system, so system could be anything, right? So if you people usually refer, like if there is a body or government that is functioning, they do many things, like for public, or there is a policing, so that is also a system, right? So those are like physical systems, but when we are building these virtual systems, like basically to, and essentially we also do the similar thing to solve the problems, right? So if there are like ways to do something, it could be solving a problem and help people to increase their performance. So basically we need a set of tools and techniques, and we call them this is our system. Our system is functioning, or system is not working, or system can be improved, right? So that is very generic term. So if I talk about system is a way of doing the things. Then, like, once we have a system that is a way of doing the thing, basically we need a design for that system, right? So to solve those problems, basically this system should have some structured or defined or controllable meaning for that, and that is known as design, right? So the way in which something is planned or arranged. Okay. And guys, these sessions would be interactive. It's not like any other session where like you are just given a you are writing a code and then showing. So basically, as I mentioned, these interviews are always open-ended. No answer is right or wrong, but only thing is you should have a reasoning why you are choosing and what is the trade-offs, in what situation you are using those things. Basically, you should take a stand and justify whatever you are thinking. It should be correct according to you. So yeah, so these sessions, basically we vocal, we participative, and always I'm adaptive to your feedbacks and would try to adjust and adapt everything. Okay. Okay. So yeah, the way, I would say, in which something is planned. That is basically a design. Okay. So when we and like combining these two things. So after knowing system is way of doing the things, and the way these things are basically planned or arranged. So that is basically we call a system design. Okay. So let's talk about the basically interview structure. Okay. So let me change the pen. So let's talk about this. So let's first understand why these interviews are needed basically. And the people who are having more than 3 years of experience, actually, apart from writing a code, they are also expected to um have a knowledge of system design. Okay. And what is the purpose of having these interviews, and basically mm, what type of questions are asked and why? What is the intent behind that, right? So like you have first thing is um, to assess the candidates communication basically. Okay. So how you communicate your thoughts. Maybe you are interacting with a customer, or you are interacting with your teammates. Basically, you need to influence, or whatever solution you are coming, people should be convinced with that. And that is needed in a real time, day-to-day job, that is required. Okay. So communication is very essential part, how you communicate your thoughts and how you represent your thoughts into a design, right? So that is assessed. That is number one thing that is evaluated in these interviews. Then basically your technical abilities. So in tech skills, basically what we are looking for, if you know a number of technologies, programming language, databases, right? So if you have been given a problem, how you adapt to that situation and how you approach that problem and how deeper you think. Okay. So before applying those technical skills, like you need to communicate your thoughts and come up with the best approach. So it should not like over engineer. If you know the microservices, but you should also know what are the basically benefits that monolith system also offers. So can you, someone volunteer and tell me what is benefit of monolith services?
Easy to
I think
maintainability.
Okay.
I think it keep things simple. If you're doing a simple thing, it just keep it simple. It doesn't involve more complexities, because with more fine-grained design, you also have fine-grained challenges to deal with.
Correct. Correct. Yeah. So idea is like if you know many things, you know microservices, but it doesn't mean everywhere you are going to use those microservices, right? So yes, so it's always expected to know the trade-offs between the things, and that is another aspect that is evaluated in these interview. Trade-offs between choices, right? How you are making the choices given in a circumstance, right? And fourth point is another thing is how you respond to pressure or stress situation, right? So suppose you are asked to, so the intent behind that is like these questions are kept vague intentionally. So maybe you are asked to design a chat messenger, so that is a one liner requirement. So nowadays, like your business or your PMs, they do come with a single line of requirement. If you are working in agile model, you may have witnessed like you are given a requirement in a single sentence. Okay. Now to like decompose that or understand that, so other thing is you need to, so those are kept vague. It's your responsibility to ask those questions to create a requirement, basically to understand the requirement. So that is another thing. And maybe questions are kept vague and cryptic, basically to assess how you perform under those stressful situations. Maybe you are thinking about something and you shared your thoughts. So whatever are your assumptions, basically you talk louder about them, and then you show your strength of how you perform in those pressure situation, even in real life if those things come in your during your projects. So how you respond to those challenges, basically. So that is also assessed. And other thing is requirement gathering. So how you gather the requirement from basically those one liners. What if one line of requirement is given, basically how you abstract and come up with some MVPs about from that requirement. Okay, so does everyone know what MVP is?
Minimum viable product.
No.
Minimum viable product.
Yeah, MVP is basically minimum viable product. So from the requirement, suppose if someone asks you to design a streaming service, right? So design a streaming service like YouTube. So do you think in that time of 45 minutes, like 45 minutes, you can design YouTube like system? No, right? So even not coding but designing also, you need to do many probing things. You need to understand all those features. So if you go to, so any problem, whenever it is giving, just think about the real time, what you have seen and what features and what functionalities that system has been offering. So for example, YouTube, so if you go there, you log into page, so first thing is you interact with the login page, then you are landed to a home page. So that home page has some auto recommended videos which you have seen in past. Based on that, your then there are different sections, like you have profile, you have videos which have you seen, history, then there is a creation screen, like you can create a content and upload that content, then you have a dashboard, right? So there are a number of features that one product offers, and designing all those features in 45 minutes, it's not possible, right? So basically, to understand what are the MVPs, it is needed. So like think loud and come up with all those, like these are options in which you are interested. So your interviewer should clearly, you and your interviewer should be on same page to like what piece of that system you are going to design. So for example, even if you have to design the login thing, login page, so there can be multiple type of logging. So there is OAuth2, or you have email based authentication. Do you, how you handle the forget password? So those use cases are there, right? So even that in itself, it's good enough challenge to solve in 45 minutes. So that's why basically those questions are asked in system design interviews, and they are assessing your skill sets through those situation based questions. Okay. All right. So the other thing is like there are some prerequisite. Before going to few concepts, I think because we have, I missed that part. So we have a mix of audience, and everyone has a diverse set of skills. But like for the system design interview, what are the prerequisites? Let me talk for a minute about that. Because we are going to cover HLD and LLD in these sessions. So first thing is prior coding experience is needed. Okay, so any programming language, you should have any object-oriented programming in past, because for design patterns or those machine coding, in that you need the coding skills. So that is number one prerequisite for with this course to move forward. And other thing is like knowledge of any object-oriented language. So it could be Java, C#, Python, or anything where you can have even JavaScript is fine. There where you can have the basically the concept of classes and object, that should be sufficient, and some understanding of SDLC. So what SDLC is? This is software development lifecycle. So like the when a requirement comes from requirement to designing to writing code to deployment and keep the services running. So that is a life cycle of any software development project. So there are different models, or people say that like waterfall model or agile model. So agile is in practice, like most of the companies are using agile. So basically you should be having understanding what are the different stages of software development. That will help. And you should be knowing the basic concepts like what is the client and server, right? Client server and operating systems, networking. And good to have cloud computing. So when I say cloud computing, maybe like when we talk about the scale and software as a service, so those things, APIs and all, how you are hosting. So like that is good to have, like if you know those terminologies, maybe here and there we are using those terms. So you are following along with the class. Okay, so these are some basic prereqs. Basically, these are good to have. Even not, you can ask and we can discuss. All right. So, yeah, coming back to our original topic. Yes. So before jumping into further, let's talk about some fundamentals. We use just one term, SDLC, right? So what is SDLC? What is the software development life cycle? Okay. So at high level, if we see what are the different phases, and I'll talk about like why we are discussing this here. Okay. So what is the first phase of SDLC?
Requirement gathering.
Okay.
Requirement gathering, yes.
First is requirement, and then second phase is
Design planning.
Design, and then
Coding.
Coding, or we can say execution, right?
Execution.
Execution and
Testing.
Testing, yeah. And the final part is
Deployment.
okay. So why I was talking about this? So who do you think is responsible for this phase? Who does the requirement gathering, or who are all people or roles which are responsible or involved in the requirement phase?
Business analyst.
System analyst.
Okay, so we say
Business analyst or
analyst,
okay.
or basically okay. Or so first thing is basically PMs. We say product managers or program managers. Like so, analysts will come later. But first thing is like you should have a business, right? So like all those stakeholders I'm talking about. Okay. So you have a business. Business gives requirement to project managers, and they come up with the some solutioning part or documentation part, and they give it to analysts. But basically engineers are also basically that at the end engineering teams are also needed to engage, basically who will execute. So there are multiple actors in requirement phase, right? So your business will come up with some requirement, like I want an e-commerce platform like Flipkart, and then you would have, so what are all the features? Basically they will tell some features like we want to set we want different parties, like a platform for seller or buyer. Basically what all these e-commerce platform are doing, basically they are providing a platform where seller and buyer can communicate. Basically these e-commerce companies, these are technology companies, basically internet companies, but they are providing a platform between these two actors. Basically buyers, sellers, they can list their product on my platform and buyers can buy. So that transaction, financial transaction that is happening between them, I'm working as a mediator. Basically I'm solving their problems. So buyers get a platform where they can list their products rather than having a physical store place, and buyers, rather than going to shop or walking to a shop, they can basically go online and purchase the products they are looking for. It could be any e-commerce site or any business requirement. So basically your business investors, they want some, they have some business idea. So when that idea comes, they want this type of platform, so they hire the professionals. Basically we say PM or you name anything, they basically will go them like further drill down the business needs into requirements. Basically for, so when we say requirement, this requirement is for engineers. Okay, so there was a business requirement that was communicated to some person, and this person then further drill down that problem. Basically they need this website that should be available. So what PMs will give you, basically some NFRs and functional requirements, right? So they will just talk about like I'm expecting a traffic, and those questions, I'm expecting a traffic of 100,000 people coming to this platform, and it should support all. Based on that, they can plan the budget and all. And then you can say those PM or analysts, they can coexist. Those are the same people. And ultimately, whatever that requirement is, it is communicated to engineering teams. So engineering team has different actors. You would have engineering manager, you would have testers, engineers, all those people, scrum masters. So all those are part of this engineering team who do act on those requirements and start the ground, or from scratch they create a ground for deciding what technology to use to fulfill this requirement. And basically that is the part of uh, engineering team, basically to gather the requirement. And then comes the design phase. Okay, so this is a pure engineering playground. Okay, so once business has given the requirement, and now requirement has been understood by engineering team, now what is the next step? So basically who is responsible for the designs?
Software architect, system
Okay.
Lead architect.
Architects.
Okay. Okay. Yeah. So do you think only nowadays with the agile model, you need architect for each requirement? Like always there should be architect, or engineers can also take that charge and they can propose solutions?
Engineers also
Engineers
can
can also
take.
take the charge.
Yeah, Pramod, and not only just in Agile, Pramod. I remember even during my second year of work, I was part of a team when the architecture design used to happen. They'll include all the engineers as well, at least those who are going to
Yeah.
primarily work on it.
Yes. Yeah. Yeah, that's a good point. So it's yeah, architects are needed. Suppose you are writing a product from scratch, or you have selected a technology. Maybe they are exploring the trade-offs between what technology or what tech stack to use, considering the budget and everything. So it's not many teams, they can't afford the architect or those names. So maybe someone has a startup. Suppose you got an idea, you are an engineer and you are in your college itself, you started writing code. So do you wait for architect? No, right? So architects are responsible, that is one role, but mostly the design is done by engineer. So suppose the product is running and you have written that piece of code, and one change came into that, and that change, let's take example. So suppose you were storing all your persistent data in a database, for example, MySQL, okay? And there was a huge read requirements, and database tables are growing and they are taking so much disk space. Now you need to think about something like other alternate options or optimize that performance. So maybe you as an engineer has written that part and you need now to optimize for your module. You need some lift and shift to accommodate the new requirement. So you will take you will suggest some solution, you will come up with some design, right? So that is done by, so basically that is done by engineering teams, not specific to only architect. Architect is a role. They are basically responsible to set up vision or guidelines for larger teams, but in smaller teams, maybe anybody can play that role. And for example, when you are in your this agile model you are following and you have a planning, in that planning you discuss the requirements, and people can take some exploratory work. Maybe at the end of sprint you have to deliver something. That's some working model, that is a philosophy behind that agile mod. But before that, maybe there is some exploratory requirement where you need to explore more about that what are the design options. So like because team that is managed by the team, so people who have found that piece or some knowledge, they agree to take that piece, they can take and start exploring that and come up with some design at the end of the sprint, so that that can be prioritized, or other people can also collaborate and start working on that model. Okay, so that is design print. So what is design basically? So what is the outcome of this design? Role we understood. What is the outcome of this design? Okay, so basically this is a blueprint. Okay, blueprint about tech stack. Okay, and the flow of the system. Okay, when I say flow, basically how components in a system will interact to fulfill that business need, the requirement, so-called requirement may be further drilled down to in the pieces of unit of work. So basically to complete that unit of work, for example, placing an order is placed. So basically what are different stages, like accepting the order, validating the order, and then generating the required metadata for that order and storing in the database. And once that is stored in the database, you displayed that information like this order with these items has been created. So that is a single unit of work, but there are different phases, different components which need to interact, and that is your flow, basically how end-to-end flow is working. Okay, and then so this is design, but what are type of designs, right? What are different type of designs? Then comes basically that the purpose why we are here. So we have this
high-level design, low-level design.
low-level design and high-level design. Okay, so can anyone volunteer and talk about what is high-level design?
High-level design talk about the non-functional requirement as well as the scalability, maintainability, what is the load.
So only NFR you are saying, only non-functional requirement?
No. Mostly non-functional requirement, but it also contain other requirement also.
Basically, we don't go into deep like on API level. We just talk about the structures and how the functioning would work.
Okay, yeah. Yes. So basically, it's not only NFRs. So when we say high-level design, so requirements, like in requirement phase itself, we got the requirement. Now we are in stage of designing, right? So this is if you talk about design, high level design particularly, you got the requirement, you broke down the requirement. So those functional and non-functional requirements are basically part of this requirement phase itself. So requirement is already given, and as per se, if I talk particularly for these interviews, what would be your approach? So maybe one liner requirement is given. So design a chat messenger I talked about. So that is a requirement. Then before going to design, it's your responsibility to extract that requirement and scope out the requirements. So there are few things. Yeah, we talk about functional requirement, non-functional requirements, scope, okay, out of scope, or assumptions. So this is for interview point of view, but in actual how we do. So these things, suppose as part of requirement itself, you captured basically what are MVPs we just talk about. So what are the things I want to do? So basically I would talk about, for example, this e-commerce side. So this order flow. So what would be the functional requirements? Like accept the order, okay, confirm the order, or there can be requirement modify the order, delete the order. All those are some basic functional requirement, and maybe out of 3-4 you can say let's focus for first two. Maybe it is a low level design, so maybe accept the order and cancel the order. Those two are the requirement. For that you will design the things, and what things you will design we'll talk in a while. And then comes the non-functional requirements. So non-functional requirements are basically that characteristics that are needed to support that system. So when I say characteristics of the system, so that system, how it performs in certain scenario, when there is a peak load, how the system will perform, how many active users can be there, right? So all those are non-functional requirements about the system. And then you talk about scope. So scope is just to like limit between the functional requirements. So in functional requirement, you talked about these 5 things are needed to keep the system running or build the system. But what is in scope and what is not in the scope, what is the first priority? So in that you can set up the priorities, like first I will do this. Even in real time also you set the scope, right? So at the end of this month I'll deliver first 2 options, like users can log in and create a profile, then I'll say coming soon, like that, right? And next month I'll start allowing it. That is how that agile works, or any system. You like create scope and non-scope items basically to have clarity, and those assumptions also. So this is specifically for the interview point of view. So in interview you can talk about your assumptions. So if you are suppose building a system, for example e-commerce system, so you can assume like there is already a payment gateway that has been configured, or I'm assuming like already one database has been decided and it can store the information, so I don't have to build the database from the scratch. Or I can assume like users already have an interface to log into system. For example, I'm just designing the one feature into that, for example chatting feature in that system. So I can say like other things are in place, I'm just focusing on that. So those assumptions you can basically list down there. So this is the part of requirement. But in high level design, what we talk about basically components and the actors. So who are the actors, who are the users basically that will use this system? And third thing is what is the flow? Okay, so how those components basically will when we talk about low level design, like oops concept, we'll talk more about those different type of diagrams and all. But for now, like what things are captured in high level design. So basically in high level design we do have those components or building blocks. So you can think of like you create those actors, like this is the person and this is my system, and they send a request to the system, and then there is a, for example, another component that fulfill this requirement, and then it sends back the response to user. So you can think about like client and server sort of architecture where the things work end to end. So those things needs to be captured in high level design. Okay, and then comes low level design. So what is low level design? What we capture in low level design?
The API functionalities, how the system would work, what all will be called for for working of a particular feature.
Yeah.
Basically, so how do you implement from high level to low level? I mean, how do you convert this to actual implementation, a comprehensive implementation from high level? So that is what is low level design.
Yes. Yeah. And thanks for answering that. Yep. So how this flow works? So basically, requirement gives you requirement document or whatever format you are capturing the requirement. So that outcome of requirement is input for design phase. Okay, and in design phase, like you have a high level design, how you translate that high level design into low level design. Basically, that is what. So the output of high level design is the input for low level design. So like these are two components. So these are two services, or these are the actors. Okay, so how you represent these actors basically. So when we say system design, you can think of this as an object oriented system design, and when we say object oriented system design, that is a low level design. So we are basically translating these actors. So I said this is a user, and the user name was customer, right? So it was a customer. It can be a seller. Okay, so we need two different classes, and maybe to optimize that we need some class diagrams, right? So basically, in this entities and schemas, what table you will use to store that data in database, right? So that much detailing. Okay, and what else? So like classes. Okay, classes and objects, and how you design those classes and objects. Basically, you have some abstraction, you write some interfaces, then inherit those interfaces into classes, and in classes you design the so what classes contain? Basically, they contain some attributes and some operations, some methods on those objects. Okay, and then how you implement consume those objects and classes using some services. So we talked about e-commerce example. So e-commerce website. So like this is a customer. So what customer will do? Customer will list the projects or upload the products, product information, basically, not product. So they will upload the product. So upload product is a method, but using what? There could be some service. So service name, you can say customer service, right? So customer service will take customer as a object, and that customer service will also take a product as a input. So combining that customer and the products, you create a method upload products. So that method you will implement in some service, and that service can have multiple classes, basically. Okay, and those basically entities and classes that can be static or dynamic, and there can be stage update from one state to other state, transition is happening. So that flow, basically. So in low level design, we have like these services and diagrams, basically. So what diagrams? like you say use case, okay, or class. So basically you captured the high level requirements, you identified what are the actors, what are the components, what is the flow, how information, who will do what, basically in business terms. So that you captured in a diagram, you designed the flow like there will be three services, one order ingestion service, other is the order processing service, okay, and other is the dashboard service, for example, for sailor only. So I'm creating these three services. So I will depict that in diagrams. I'll say this is a sailor, he will interact with this service, and it will have another, it will call another service, that service will call some database, okay, and from database, and the service will read the information and display to the user. So that is a high level design. But when you go to low level design, basically you translate those actors and objects into a design, low level design, basically. So if you see anything, for example, you take aeroplane. So aeroplane is a physical model, but when you translate into object and class, you say like aeroplane has this fly capability. So that is a function. Aeroplane has a name, it has a source and destination, like those things. When you translate that into a technical requirement, that is where this low level design comes into picture. Okay, now we discussed about low level and high level design. Any questions, any thoughts which I missed about the concept of low level and high level design?
Pramod, can you tell one more time the first point in low level design?
Yeah, so I talked about entities and schemas, right? So like you captured, for example, this sailor. So sailor information, where you will store, you need some database table where you will persist that information, right, going forward. So you need to design the schema. So in, for example, there is an entity named sailor, and it has the sailor ID, sailor name, onboarded date, all those fields you will design, right? So that is a low level design of like translating that here. If you see high level, so there is a component or one entity that is a sailor. It interacts with the system. How you translate this into low level design? Basically, you need some placeholders in your database.
So the logic and everything can be under low level design, right? What logic we are going to use, and how the different components are going to interact with each other. So that all things come under LLD, right?
That comes under LLD. So yeah, we say UML. So UML is a notation. It's not necessary you use UML only, but that is a industry or standard practice people are using, so that non-technical users also understand what things you are implementing, basically. So there is no code involved in this low level design, but to identify the basically how you are translating real time components into low level design or objects and classes, basically.
So one more thing, high level design, I'll say I have after the requirement gathering, I have created an architectural diagram. So that should
Correct.
be coming under high level design, right? And
Correct.
if I'm further defining it, the logic, the table, the schemas, the database objects name component, that will come the low level design, right?
Correct. Yeah. So I said,
sorry to interrupt. I have one question. So few things which is not there. I'm just a little bit confused about it. So how about the physical and the virtual layer of the system? Like what sort of infrastructure we are going to use, going to be our on-premise data center, or we are going to use a cloud vendor? And if that is the case, what kind of system, like what kind of operating system we are going to use, and how do we?
Yeah, that's good question. So that comes under these components, right? So that are the services, technology stack, and all that you decide in high level design itself. So suppose you decided to use Cassandra for your persistence, right? But what would be the structure? What information you would be storing there with respect to any components? So component, there can be a number of components and services when you drill down, right? So those services will emit some data, some information. So how you will translate that information, and you will design some contract. So for example, your customers are calling your service, so you decided to make let's take that example only. So you said this is a order API. So API is basically application programming interface, and that is being for example exposed to customers. They onboard to this API, but this API will require certain specify some contract, right? You would say like, using this contract only you can send a message or payload to this service. Okay, so I knew this is the service name, but what this service will use. So this is my high level design. I decided this is a service that is going to be hosted as a web API or front end, but to exchange the messages between different parties, how it will take a message and what it will respond, it needs some contract. So that contract could be order info or sort of thing, and where you have these key and value pairs, ID and name, all those fields. So this will fall under low level design, and the other part is high level design.
Thank you, Tansis.
Okay. All right. Yeah. Any other questions? Yeah, we need to understand this very clearly. This is a bit theoretical, but still, like, we should have a very clear understanding what we are doing in low level, because there are interview types basically. So I was supposed to talk about. So
for my designing, say I'm working on a distributed system, the pipelines. So the considerations like this much memory I would be needing for my master nodes. I'm just going for a very layman term because I don't understand much. So these factors, how much scalability I need to have, because this all comes under low level designing or high level designing.
High level design only.
The hardware, right? Yeah.
Yeah. So technology choices, yes. So what technology choice or what components you are designing? So I think I should have mentioned the tech stack also. So that is, but SQ basically what tech stack you are going to use. So basically a component, whatever it needs, that you will detail down in your high level design itself. So database, what database you are using, you will decide there. But to translate that database actual implementation sort of thing. So maybe in a minute I'll talk about the next step, then you would have more clarity. Give me a minute. Let me talk about these three things. So interview type in like design interviews. So many companies have like this HLD round only. Maybe someone has this 10-20 years of experience. They are not asking you to write the code and just come up with this high level design. Here you come up with the flow and what components are needed. Okay, and tech stack, what database or what characteristics basically like load balancers or sharding, caching, right? So all those, what arrangement of these things, how you are arranging these components or characteristics to fit your requirements. So that is covered in high level design. So high level design, these things are being asked. Then comes this low level design. In low level design, what they expect you to basically have use case diagram. Okay, so where you specify what are the actions these users are performing. I said like in high level design, I could have designed service, and I said this service will have these dependencies or scalability requirements, caching requirement. That is fine. But if what particular function, so maybe one service has for a very standard way we can take these CRUD operations, right? So any service will perform that CRUD operation. Basically, it has some create method, okay, read method, update method, and delete method. Okay, so for one of these, basically you have to write a code about how this create works end to end. So that will fall under this low level design. Or so I said use case. In use case we have these three things, like I will create, read, update, and delete. These are my use cases. So I said I have an admin user. Admin can perform these use cases, basically these use cases on my system. Okay, so you can, in low level design, you can expect like this use case diagram, and you can have a class diagram. So for class diagram,
Sorry, DFT diagrams come under which category, whether HLD or LLD?
LLD,
DFT, okay.
data flow diagram.
Yeah.
No, what you said, DFD.
Yeah, DFT, data flow diagrams, yeah, exactly.
Yeah. So okay, so data flow diagram, actually when you go to UML, right? So UML has different type of diagram, like sequence diagram, class diagram, use case diagram. So data flow basically is one of the scenarios where you have to take a decision. For example, I want to delete a user, right? I have this users database and I am admin. So as an admin, I need to delete a user. So what would be the flow for that, right? So I will start from here. Okay, so first, for delete, what I need to do? For delete, I need to search, right? I will perform a search, because if I am not seeing the user, how I would delete? I cannot directly delete, right? So in search, I will have some flow. I will say user found or not. Okay, user found. Then I will take a confirmation. Not found, I will again search, right? This is the flow. So this is a data flow where we have to make some decisions. So that flow is not for entire system. I cannot design a flow for entire system. In entire system, high level, like it is set up systems. But when I go to component level, like this functionality I was talking about, this CRUD operation. So to create a user, I have to design a flow, data flow, basically how data will flow from here to there. So that falls under low level design.
Okay, thank you.
Yeah. Then in low level, you have this schema, and like I'm talking about interviews. So interviews, you will have this high level interview only. Most of the cases, some companies are asking low level design. In that, you are expected to write use cases, class diagrams, schema, and basically design patterns. So why design patterns? Basically, when you are designing a scalable system, your system is extensible, you are using a singleton pattern or factory pattern, you have to not just you came up with this order system, or you have a customer class and customer can add, edit, delete. But maybe tomorrow there is another feature that is needed for the customer and you wrote just a class. That is not a good practice. So with your experience, it is expected to have that thought process to make your system decoupled and scalable. And to achieve that, you need some design patterns. So you may be expected to write some code, some classes. Okay, so for example, I can give you of Amazon. So they have one round of this low level design where they ask you to translate a complex system into an object oriented system. So one good example could be design a elevator. Okay, so you have a elevator lift where maybe there is a society. In society there are multiple elevators. Some are like, if you go to further drill down those details, like how many number of floors would be there, what would be the options like buttons outside the elevator and inside the elevator. If elevator is going in upward direction and someone press the bottom direction, how it will react. So how you, because that is very vague and looks very complex system. So you need to think through like what all classes. It's not like that is not a distributed or microservices sort of architecture, right? So that may be a system that is running on a device and it should have some intelligence. So how you translate that elevator into low level design? So basically you need to identify what are the objects and what are the classes needed to translate that elevator functionality into low level design. Or for example, you have bird. Okay, that is basically you can say bird is an object, and how you translate that bird object into low level design, right? So you would have a class like bird, and bird would have some like category or type. What type of bird is that? What things it can do. It can fly. So fly is a function that requires the bird, right? So how you translate that? That is expected in low-level design. So a very clear understanding and deep thought process is needed to come up with a good solution. Okay, and third is machine coding. So many companies like Stripe, they are asking machine coding. So people think like having like this problem solving data structure type of interview. Okay, so non-DS. So I'm asking you to like sort an array or write a DFS or BFS code to find the minimum path or those things. So basically many people are not comfortable with that. So some companies are getting away with that mode of assessing the interview. So they are having machine coding round. So machine coding, what it is? Basically collaborative platform. So your interviewer is coming with some real-time use cases or scenarios. So they will give you a real-time code example. For example, I'm building say a flight booking system. Okay, so flight booking system, there could be some predefined features. So I have to implement the flight search and book. These two methods I need to book, and you can imagine there is a flight class and there is a reservation class. All those things are given. So that is a collaboration. When maybe your interviewer will come, he give some snippet of code. Okay, and that snippet of code, they want you to extend some functionality. Okay, so and run that code. And some companies, they are allowing to Google also. You can Google in front of interviewer and basically come up with a solution for that. Maybe you don't know the syntax and all. So those people give you some flexibility to take the help of those online resources, Stack Overflow and all, and then you come up with a solution. So these are basically types of interviews, and each interview has some expectations. Okay, so I hope with this discussion you understand what is expected in these type of interviews. I'm
So we
taking
have
pause
to
for
write
any question.
so we have to write the code in the machine one.
Yeah.
Hello.
Yeah. So you have to write a code in both this LLD and machine round. Machine round is mostly focused on like that bug-free code that can be compiled or anything. But low-level design, you have to write the classes and diagram. Maybe that can be whiteboard also.
Pramod, one doubt here is like this machine coding round usually it's used to be happen in the service based or even in the Microsoft, like it was in the Microsoft services, global delivery services. So even in the product departments like IDC also, they are now taking this machine coding, or it's
it depends on teams sometimes. So suppose I am an interviewer, like my team, I have to hire 2 engineers and I need immediately they to be productive, and some problem maybe it is pending and someone resigned and I want a replacement and quickly I have a timeline. So maybe I don't have that much value for other things, and as appropriate hire is there. So they decide like, okay, person already knows the Angular JS, and where the last person left, he can immediately contribute, right? So what
okay.
I'll give some Angular JS code snippet and to check actually he has worked or not, because service companies, what I see people do ask mostly theoretical questions. Do you know
Yes.
this? Do you know that? So that
Yes.
I personally don't find very productive. Okay, so
Yes.
person may have like maybe he is very good in writing JavaScript code, but he haven't gone through those theory part.
Yes.
Okay, so that's why like it's not limited to company type, product or service or whatever company. It can be asked anywhere. So you should hands on and ready, or you know before going to interview, you know whether you are comfortable with that or not.
Okay.
Okay, yeah, I think Nidhi was asking something. Someone has a question, I think, in between.
And Pramod, one more question is like what I came to know from the other people in the tutor also, like persons who are having like 10 to 15 years of experience or more than 10 years of experience, like more focus is giving on the system design instead of data structures. So is it true, like for the interviewing, like?
And so what is the question?
For persons who are having more than 10, 12 years of experience, the more priority is giving on the system design, more questions interview will be focused on system design part rather than the data structures and algorithms part.
Yeah. So maybe like these companies have 4 to 5 rounds of interview. For example, if you take Google's example, so they have like those 4 rounds. So 3 rounds are, there can be more rounds, but the core competency, for example, an engineer, so they are asking 3 rounds about the data structure and problem solving, and 4th round is system design. So if you clear all those 3 rounds of coding, then only you are given that system design rounds. And sometimes companies have phone screen also. So those phone screens are basically these DS and algo questions are coming through HackerRank or on a platform. You write some code, so they feel like you are good to go for on-site because they want to save some time for interviewer also. So that is a filtering. Maybe they are outsourcing to some companies like Karat or Barrager. So that phone screen is through, then people go through those rounds, but depending on role. So if someone is coming for a staff engineer and a principal engineer or an engineering manager, so there would be these, there are only 4 rounds. So maybe first 3 were tech round, okay, but for engineer, maybe those round. So if I say engineer or lead, I would say. So if I say lead, maybe it is staff or principal, right? Or EM sort of role, or senior engineer, even senior engineer. But here, if you are going for pure IC role in individual contributor, so round would be like DS and DS and design and one culture fit, right? So these rounds are happening. But if you go for these lead, maybe first round is DS, second is DS, then design. There are 2 design rounds usually. Okay, then culture fit, like this. This can happen. And suppose, for example, you are going for engineering manager, so this round is about 2 design rounds are there. One is about people management, okay, and one is coding round, maybe one DS round, one people management round, and 2 design rounds, and then culture fit. And maybe one of them can be dropped, only one design round, one people management, technology management, like that.
Okay. Thanks
All
for
right.
the presentation.
Yeah. So hope you are clear about what to expect in these interviews, right? So you should stick around these, like now I hope you understand what is high level design and what is low level design, and what to expect from interview point of view, and also in actual implementation. So what things you take care in high level design, and what things you would need to take care in low level design. Okay. So till now we were in this design phase. We talked about design only. The next phase is execution or coding phase of SDLC, right? So once you have written the basically you understood the requirement, you came up with low level design and high level design. So that low level design is passed to engineers who are working on coding. So your delivery becomes very fast, because already you have in low level design, so you have like these UML diagrams where you design the basically use cases. So in use cases, you know that actor and what are the basically activity they are performing. Then you have sequence diagram also. In sequence, you design like what is the sequence of events, how it is happening. Okay. And you have defined the classes also, class and interface. So you have given the interface name You have not written code for class, but you have given like this will be the interface, this will be the design pattern, and this class will inherit this interface, and what methods are needed, right? So you have given the methods also, operations basically. So operations like this class will have these many operations, and these are the parameters which are needed, but logic is not written. You have just given the method name to save into database. For saving into database, he needs a connection string and take like serialize, deserialize that object which was coming as an input, and he can invoke that method to save into database. So these things, if you are done already, okay, you have set that guideline, so productivity becomes very fast. So engineer just have to create a class file, and in that file he knows like this is the class name and these functionality I have to implement. So they just are worried about writing the method, that operation, and then they write some test cases. So testing is also like, because unit testing you are doing, or integration testing you are doing, you need to come up with some test cases. Okay, so who provides the test cases, and at what stage that should come? Can anybody volunteer to answer that?
So QA will provide the test cases. I mean,
yeah, so nowadays like there is no QA. So
okay.
yes, that is one thing I wanted to talk about, because you all are aiming to have these product based companies interviews. So everyone is engineer. There can be PMs or engineering managers. I'm not talking about that, but everyone, what I have seen in my career. So earlier there has been different teams. There have been multiple people. DBA. There was service engineer. Okay, and then there was tester.
Sir, for QA, yes.
Yeah, tester. DevOps.
So for QA, sorry to interrupt, sir. So for sir, QA, the new title right now is SDET, Software Developer Engineering Test.
Yes,
SDET.
yes, yeah. That title has been already there for a long time. So SDE, and so these are like if you see these FANG companies, basically they had this title. So you see like Microsoft, Amazon, or Netflix, they had this title like SDET. Now this title is also eliminated. They all are SDEs. And I'll say, and that transition I have seen. So like this DevOps guy has gone.
Okay.
Tester is also gone. Service engineer is also gone. DBA is also gone. Only thing is left is engineer. Okay. Only this person exists nowadays, and each company is becoming a tech company. So if you see like any company that was dealing with automobile, so there is a driverless car. So most of the things like they need lots of coders, lots of developers to write automation. And if there was a factory which was doing lots of productivity and production, they also have IoT sort of devices and machines or robots which are doing the assembling and all those things, and those are controlled through software. So software engineers are at the center stage. And why DBA is not needed? Why system? Do you think without these functions any software can run? It cannot run. You need a database engineer, but now since everything is moving into cloud, okay, earlier you had like infrastructure on premises. So you have some machines, some hardware, so to maintain that provide a networking connectivity when machine goes down, ordering a new machine. Okay, all those things were done by the service engineers and DBAs. They were recommending, now I need this terabyte of data to database server to install a Oracle on that so that I can run the database. Now that is not needed. Everything is provided is on rent basically. So that everything is moving to cloud. So in cloud, they have a leased data center which has all these functionalities already installed. There are dedicated engineers who are working to ensure those things, and they are providing a platform where you can go and purchase a service. You can purchase a database, whatever space you use, they will charge for that, but that maintenance has been gone. But who is needed? to basically, yes, in database, your in cloud, your database moved from on-premises. When you had on-premises, you needed a DBA because you need a permission, authentication, authorization, all those things, and access permissions. But now, because it is in cloud, so that is offered as a service, and you in your as an engineer have to integrate with that service, right? So how you integrate, like basically this cloud, they are providing APIs basically, or HTTP methods. So you need to write a code to create a database, delete a database. So what term is being used? Infrastructure as a code, right? So infrastructure as a code is terminology being used to manage the infrastructure or resources. Any server goes down, you have a self-healing service that auto starts that server, and you get a notification when that server goes down, right? So you don't need dedicated person. So everyone is becoming engineer, and like DevOps. So deployment and monitoring the service, telemetry, everything like can be done using code. So I have seen in my career, like people who were testers, and then people who were DevOps or service engineer, they were offered a role to become an engineer. Okay, learn coding. So whatever part they were doing, actually that can be done from coding. So you have this CI/CD pipelines, right? CI/CD, so continuous integration, continuous deployment. As soon your code is checked in and your PR is approved, then it will go and already you have designed the pipelines, it will auto deploy, right? So manual deployment earlier, maybe I'm old school. So what we were doing, whenever I am done with my coding, I have to go to first thing, I have to go to test engineers, and they will ask me to fill a form, and in which I will give the project details, PM details, and blah blah blah. Then they will ask us to provide the test cases also that they will test, and again they will write their own test cases. Then they will prepare a report and send me back, and they will log those bugs in a tool, Bugzilla sort of thing, and then they will not allow me to move forward until I have closed all those bugs. Then they will ask me to print a document in which I get a signature of those people who are the owners. Then I take that piece of paper to DBA team and DevOps team, and I say, sir, see, I have approval and I have permission now. You please deploy. And for deploying, I have to drop a clear instructions like, first you modify this file, enter this config for production, this config for low level environment like BP, and then you restart this service, reboot that service, and then my deployment is done. That was an old school actually. But I have seen that in my career, but now everything is done by engineers because everything is integrated with the pipelines, and you have to write a code even if you want any new thing. Your service goes down, you get an alert, you need to work on that, fix that, and basically coding is needed. Okay, so that is the execution phase. So basically your code is written, tested, tests are also automated. So you write a unit test, you write your code coverage policy in your Git repo. Once your code has a good coverage, then the requirement, basically it will go to that pull request phase, and CI/CD pipeline will kick in. It will deploy your code to the configuration which you have provided, and then your service is running. Then after deployment, nowadays no system is complete without monitoring. Okay, monitor, telemetry, and alerting, right? Why I'm talking about that? So whenever you are going to any interview, right? So interviewer will give you that big requirement, and then it's your responsibility to ask this question. So it shows your maturity. It shows your depth of knowledge. You are not just worried about writing a software. You are worried about keep that service running also, because that is very essential. So here is also self-healing, right? Self-healing. So what is self-healing? Anybody want to volunteer?
In case of failures, what will be the step? I mean to say, if some deployment fails, something like that. So backup sort of.
Some
The application should function without manual intervention. That is what is self-heal. Automatically should be able to fix the resolve on its own.
Yes. Yes. So self-healing or resiliency. Yeah, you answered that correctly. So that is basically the services should be able to self-heal. So if you have a microservice, okay, two microservices are interacting, and because there is always a risk, one network is going down, a service is down, so customers should not be impacted. Rather than a ticket is raised, some person is going manually starting that service, rather than when you know like service is down, you first thing is to spin up another instance of that service that resumes the job where the older service left. Okay, and if any service is going down, it should check, there should be some checklist like why it can go down. So you can think through and write a code, you can write a monitoring service that keeps monitoring, like if something is not processing. For example, you have a payment system and your payment system couldn't establish a connectivity with the payment gateway, right? So you should have a monitoring service that keeps looking into that queue or wherever you are maintaining the state. Like if I have a threshold, any service that is pending for more than 20 seconds for completion after retries, basically I need to kill that message or recreate a new message so that my transaction is self-healed or service is self-healed, right? So those type of monitoring things should be there. So yeah, my point was please keep these points also in mind when you are doing the requirement gathering. So when you are asked to design a chat messenger, you talked about a lot of things like this technology, that technology I'll use, and I'll also build a monitoring, telemetry, and alerting system and self-healing system to keep these services running. So writing the service is one thing, and keep the services running is the core, because that is generating a business, and business, not only business, life depends on that. Maybe some hospitals are running on those things and they are performing some operation using a HoloLens, and that is running on a software, so that cannot fail, right? So it's very critical to keep those services always running, and to monitor that, you should have a robust telemetry and monitoring system so that you can auto detect and heal, fix your problems before customers start complaining. Okay, so when you are talking about these things using the MVP terms, it shows your depth of the system and knowledge. Yes. All right. Yeah. So that was about low level, high level design, and we talked about these phases of SDLC, right? So which phase is there? Just to reiterate, like there is a requirement. So from interview also, you have to think in this flow, like you have to be limited around design only. But for design, before design, there is a requirement. So gather that requirement clearly, understand the requirement, list down the functional and non-functional requirements. Based on that, design the components. And in design, basically you come up with the blueprint and tech stack and the flow of those components, and then go to low level design where you talk about the classes and objects basically. And you should have a clarity. Also ask your interviewer clearly, like whether I should focus more on low level design or high level design. And some interviews have coding also, that's why I kept this execution phase also. So here, like you write a code, you write the test cases also. So when you go to machine coding round, maybe you are given a problem like create a in-memory search engine. So you created a classes, you wrote the methods. Yeah. So basically in low level design, so when for example you wrote a method similar to your DS interviews, right? So you wrote one algo or you solved one problem, then there are some test cases basically. So you execute your code, whatever you have written, whether this is giving a right in output or not. So for that you have to like write the test cases also. So that would be presented to you in your machine coding or low level design rounds. All right. And then finally this deployment. So this deployment, you should be knowing all those techniques and what is the infrastructure you are proposing, and what is the self-healing monitoring capabilities after deployment that you are going to execute. Talk about them also. All right, so I think we are on top of R. This was just an introduction section, and I wanted to set a context for upcoming classes about how it is going to move forward. So today, what we covered, we tried to cover the interview aspect of what to expect in interview, and what is the basic tenets of any interview, and these SDLC life cycles, and what are the type of designs, okay, and what has to be covered in which part of like low level or high level design, what is the difference between these. So those things we covered in today's session, and tomorrow we'll dig deeper into other areas, and then we'll start with the OOPS concept and low level designs.